Hey Adam, it's Monday morning in physics class. We only have 3 of us here today. Four. We'll have 3 in math maybe. So we are pushing on and talking about more on day 4, where we are learning how to launch objects upward. This person is launching an object from a cliff of 120 meters. We have sketched it. And the initial velocity is given, and we're asked to find the final velocity, which means what is the velocity right before it hits the ground. So that's the final velocity. All right, take us along this path. Which variable are we missing? So we need to find which equation to use by that technique. So Drew, do you see one that's missing from this discussion? We have to have that. We've got this. This represents one of these. Can you find the missing one? Did you say something? What is it?
X.
X is this distance right here. So we do have X, because when it finishes, it's going to be at minus 120. So it's going to be 120 below. So in a way, we have that. So we have X.
So we need acceleration.
Acceleration is also known because it's in free fall. Once it's released, its acceleration is due to the Earth. So it's either 9.8 or time. It is. You found it. All right. Process of elimination. We found it. Time. So then, Drew, which of these equations shall we pull out of our hat? Which one? Which one has no time in it? Very good. All right. So go ahead then, with that aid, go ahead and put in the values for the final velocity is what we're looking for, so you're not going to put anything in there. Go ahead and put in the initial velocity and square it. Add 2 times the acceleration is due to good old Mother Earth. And X is negative 120. I don't know how to keep it on. I thought this would block out. Oh, that's right. I need it off now. Okay. 2a, and then X is a little tricky because it ends right here. So what is X at the end of this scenario? Right where we want the velocity, it's 120 below where it started. So this number is negative 120. So we've got 2 negatives there, so don't forget that. 8.7 squared, negative 9.8, and negative 120. All right. That's a plus, not 2 equals. All right, there is a calculation involved, and then a square root. So see if we all get the same number when we plug that in. 2 sig figs are at play. So if that clock says 8:01, that means we probably take, what, about maybe 5 minutes already? So around 8:11, we'll close it and start again. It just helps me upload it in shorter segments. All right, let me see what you're getting. Okay, all right, use 2 sig figs and units. All right, you have your calculator? All right, so calculate all that and take the square root. What you got? It doesn't fall in the hole. Did you take the square root? Oh, there it is. Okay. All right. I got close to that, but not exactly. I think I might have used sig figs in the middle. So you did it. 48 and 49 are some answers I would accept, depending where you're taking the sig figs. What was yours, Jordan?
49.
Okay. All right. Did yours come out? Okay, all right, very good. So there's really no difference in doing these than the dropping ones and the cars going down the road. All right, try this one where I ask a different question. So you'll get good at these. We are at the end of this chapter already, so we were talking about testing on Wednesday, were we not? Is that what we said? Did you check your book? Is that what we said? Okay. All right, thanks, Tom.
Yes.
Okay, so I'm finishing up today. There's one more topic, and then we are reviewing tomorrow. All right. Let's go ahead and try one from our book, all by ourselves. I want you to read it, put it on the day 4 notes, draw it, pick the equation, and solve it. So just as if it was a test practice. Page 70, number 9. Adam, for you, I'll go ahead and set up the parameters. They're reading it together. Not together at the same time. So at number 9, I see someone tossing upward an object. Its initial velocity is 3.9 meters per second. And we're going to find the maximum height. So we're looking for where is it at the highest peak. All right, see if you can remember what the variable is when we're looking for maximum height. Pick out from your list the thing that's missing. That will guide you to the right equation. Whenever you're looking for a height, that's a distance or a displacement, so x, it should be your choice of what we're looking for. Maximum height. Recall, we have a little trick when we do maximum height problems. We cut the problem off right at the top. Notice I know it's going to come back down, but I'm stopping the problem there so that I know velocity final. If I stop the problem here at the top, Jonathan, what is velocity final? 0, because there for a second it stops before it turns around and comes back down. So velocity final, we already know velocity initial. Acceleration is known whenever something isn't going to be traveling straight up and straight down. It's good old acceleration due to gravity. So once again, we come to the second equation. Did you get there well before I did? All right, once again, plug it in. The last step again will be a square root. Anything yet? And we are not looking for x, are we? Oh yes, we are looking for x. We are looking for x. Yes, x should be, that might be it. What you get?
0.7, or you could round it to 0.8.
Yeah, with 2 sig figs, what would it be?
78.
Right, so that's 0.78 what?
meters.
Right, so imagine a meter is about that high, so if I toss something up, it could be 0.78 meters. That makes sense. All right, how about, Jonathan, did you come out to 0.78?
I just thought it was plain wrong.
Okay, good. Now, this one, when you move that over, it became negative, and this is negative because of that being negative. So that's okay, because you're going to divide it away anyway. All right, square the 3.9 and divide by the,
Oh yeah, no, this is mine. It was T. It was T.
And then that's to get new pants
No.
okay, 0.78. Very good. Yours work? All right. All right, let's do one of these, and I think I can end this discussion with this next one because I want to find one that doesn't use this equation. So let's try number 10 and hope for the best. Number 10, same page. So Adam, since you may not have your book open right this second, I will set it up for you. Let's read it. Read it first. Dramatic pause while they read it to themselves. We have a ladder, and when we drop the object from the top of the ladder, it goes down 12 feet. So the ladder might be on a slant, it might be a little longer, but we're talking about the actual drop being at 12 feet. And we know that it's going to take 4.2 seconds. So this will point us to a different equation because we have time this time. And we're asked to find oh, it's being tossed upward, I'm sorry. Let's say initial velocity would be 0 if it was dropped. So we're tossing it upward from the top of a 12-foot height. And we know when it leaves our hand, it has an initial velocity, and that's what we're wondering about. So find initial velocity. And all they've told us is the ladder is 12 foot high, and they've told us that it takes 4.2 seconds to reach the ground. So this is going to go up, it's going to stop, and then it's going to go down. And right here, right before it hits the ground, right there, I want to know what its velocity, now I know. It's going to happen, but I want to know the initial velocity when it leaves my hand. All right. Checking our variables. Dimitri, which one will it lead us to?
Which equation?
Yes. Which one is missing?
Half time.
We have time. Do we have acceleration?
Yep.
Yeah, always in these problems. If we're feet, what's the other number? We're not going to use negative 9.8 because this one is in feet. What is 32? Negative 32. We have that. Do we have the final velocity right before it hits the ground?
Right before.
Yes. No. V, remember V is always right before. So that's what's missing. We're looking for this. And this is going to be at the end of the problem, 12 feet below where it started. So again, we have that negative 12 number. So we have that. So which equation has not V sub O? Right. I'm sorry, does not have V sub O, does not have V. It's V that we're missing. We're looking for V sub O, so we have to have that. So which one has not V? the last one. All right, so I pulled it out, and now we're plugging in.